In this section, we're going to explore a type of problem that you might face where you are given a couple of graphs and a few equations, and you have to match them. So in this case, we have two graphs, two lines, and we're given the equations on the right. So line A is y equals x plus 2, line B is y equals 2x minus 1. Now there's lots of ways you can start this, but I think probably one of the best ways is to start by identifying the y-intercept, where the line crosses the y-axis. So in both cases, I've already got that labeled. The graph on the left, the y-intercept is 2. So in other words, it passes through the point 0, 2. The graph on the right, the y-intercept is -1, so it passes through the point 0, -1. Now, if you're dealing with an equation and you want to find the y-intercept, all you're doing is you're saying, well, what's going to happen if I let x equal to 0? So for line A, I end up with y equals 0 plus 2, which is the same as y equals 2, which means there is a point at 0 for the x-coordinate and 2 for the y-coordinate. And clearly that matches up with the graph on the left. For a line B, I have, I'm dealing with y equals 2x minus 1. So if I let x equal to 0, I have 2 times 0 minus 1, and that's obviously just 0 minus 1, which is minus 1. And so that corresponds to a point 0, -1, and that obviously corresponds to the line on the right. Now, you can do the same technique to identify any point. So for instance, you could have said instead, let's allow x to equal 2. For line A, that would mean y equals 2 plus 2, which is 4, and that means there should be a point somewhere on line A, 2, 4. And once again, I've already labeled that. You can see that point there. The trouble is that might not be as easy to identify or as readily identifiable as the y-intercept. And it also might involve a little bit more calculation, whereas you can see that the value we got for y equal to 2 is just the part of the equation that doesn't involve x. In other words, y equals x plus 2. That plus 2 part tells you the y-intercept. There's really no calculation involved at all. Let's see what the same thing would yield for line B. Y equals 2 times 2 minus 1, which is 4 minus 1, so y equals 3. So again, on line B, there should be a point at 2, 3, and indeed there is. We've got it labeled already. So let's say you've actually got a bunch of graphs you're looking at and a bunch of equations, and you're trying to figure out which ones belong with which. So let's say you start by trying to identify the y-intercept. But what if two equations have the same y-intercept? Is there another way we can easily distinguish them? So here I've got the line from above, line A, y equals x plus 2. That's the one on the left. And then I've got a new line, line C, y equals 2x plus 2. And you can see they both end in the plus 2. They both have that y-intercept of 2. And we could obviously just identify another point. And in fact, I already have another point listed here. But I want to give you a more visual way of determining which line is which. In order to get to that stage, though, we do need to do a little bit of calculation. So let's take a look at how steep these lines are as measured by the slope. So the slope, if you recall, is the ratio of the change in the y to the change in the x when you're looking at 2 points on the line. So let's do that for the line on the left. So we can draw this little right triangle between the 2 points. And then we're going to look at the delta y, or the change in the y, which is the difference between those two y coordinates, 4 minus 2, which is 2. And the change in the x, delta x, is the difference between the x coordinates, which is 2 minus 0, which is also 2. So that ratio, delta y to delta x, is 2 over 2, which is 1. Another way to understand that number 1 is that every time you move 1 unit to the right, you're going up 1 unit on this line. And so, that's the sort of steepness of the slope. If the slope were negative, that would mean that every time we move to the right, we'd be going down by 1 unit. And so it's very easy to look at a line and tell whether it's a positive slope or a negative slope. These are obviously both positive slopes. So let's take a look at the line on the right. We'll do the same thing and identify the change in the y and the change in the x. The delta y, or the change in the y, is the difference between those two y coordinates, 6 minus 2, which is 4, and the delta x is 2 minus 0, which is 2. And that ratio, delta y over delta x, is 4 over 2, which is 2. So again, if you look at the line, every time you move to the right 1 unit, you're going up 2. And so this is a steeper line. We're going up faster. So where does this show up in the equations? Well, it shows up in the coefficient on the x. So where are you multiplying the x by? So both of these lines, and now this is quite crucial, are written in the form y equal to some coefficient times x plus or minus some constant. And that form is known as the slope-intercept form. So when you have equations written in this way, you can take advantage of the fact that the coefficient on x is the slope of the line. It tells you how steep it is. And if you look at line A, you're not multiplying the x by anything, which basically means you're multiplying it by 1. So the slope is 1, so that certainly matches up with the line on the left. Line C, the coefficient is 2, and you can see that the graph on the right has a slope of 2. So we can very easily match up line C with the graph on the right, line A with the graph on the left. Now, it seems like a lot more work than just identifying a given point. But if we're just choosing between these two graphs, we can just very quickly visually see that the graph on the right is steeper. And we know that because the coefficient is 2, it's going to be a steeper line than a graph like graph of line A, where the coefficient is 1. So without having to do any calculations at all, we can distinguish between these two lines. And similarly, if we had a line that passed through the same y-intercept but was going down as you went from left to right, well, that would obviously have a negative slope. And again, we wouldn't really have to do any calculation to be able to match it up. Let's just take a look at one more quick example here. Let's say you have a graph and you're trying to identify which line on the graph corresponds to which rideshare company. So just imagine that next year, once rideshare becomes legal in British Columbia, we have Uber and Lyft. Both of these companies charge a fare similar to a taxi fare, where you have a part of it is based on how much you travel. And so let's say in the Uber case, it's 75 cents per kilometer, and then in the Lyft case, 85 cents per kilometer. And then also part of the fare is just a fixed fee, which is almost like the amount you have to pay just to get in the car. So let's say in Uber's case, it's $2, and in Lyft case, it's $1. Now, if we look at those fee structures, the $0.75 or 75 cents per kilometer, that's the rate of change, or the slope of the line. And you can see that Lyft at 85 cents per kilometer has a steeper slope. It's a steeper rate of change. It's going to be more sensitive to changes in the distance. And so right away we can tell that Lyft is the blue line and Uber is the red line. And perhaps even more easily, we can just take a look at that fixed fee. The Uber fixed fee is $2. The Lyft fixed fee is only $1. And that corresponds to our y-intercept. It corresponds to where it crosses the y-axis, or in this case, the axis representing the fare. And if you notice that there's a 0 at the bottom of that, which means that 0 distance has gone, and you're having to pay either $1 or $2. And so again, it's very easy to distinguish the blue line represents Lyft, and the red line represents Uber. There's also one interesting point on this line that we're not really interested in for the purposes of this section, but nevertheless it's an interesting point, and that is this point right here. Sorry. And at that point there, you can see that the Lyft lines and the Uber lines cross. And so that would be the break-even point, which corresponds to 10 kilometers. So obviously, if you were going on a journey more than 10 kilometers, you'd want to travel on the company corresponding to the red line, which is Uber. But if you're going on a journey less than 10 kilometers, you'd want to go on the company that is the lower line, which is the blue line, which is Lyft. All right.